Hello everyone. So today we will solve one binary search problem. This binary search problem was asked by INDmoney. I faced this problem while interviewing at that company. So let's look at the problem. I couldn't find this problem on LeetCode. And talking about the interview, so this was my first round for SDE role at INDmoney, and I was able to solve this problem during the interview, and I was selected for the next round. So let's see the problem statement, and I will tell you how to solve it, and we'll implement this problem also. So the problem statement is that you are given an array of sorted integers, and you are also given some constraints about the size of that array. So you are given that the size of array is a multiple of 4, and your array is quite big, and you have to find all the hero elements in the array. So firstly I asked interviewer what is hero element. So he told me that hero elements are those elements which are present in array, or their count is at least n by 4. So if your array size is 100, so some element would be hero element if it is present in array at least 25 times, right? So at max there can be 4 hero elements in the array, right? Let's take an example. So let's say you are given this array. What is the size of array? It is 4, right? And what is the condition for some element to be hero element? That it should be present in array at least n by 4 times. So some element which is present at least n by 4, which you say is 4 by 4. So any element which is present at least one time in the array is a hero element. So in this array, the solution for this array is basically these 4 elements itself, because they are occurring once. And now let's talk about this array, which are the hero elements or hero integers in this one. So again, the size of array is 4. So this one is a hero element, right? And then this 2 is a hero element, because 1 is present at least one time and 2 is present 2 times. So you don't need to provide the repetitive integers here. So this should be unique array that you are returning. And let's look at one more example. Let's say now you have this array. What do we say? 3, 4, 5, 6, 7, 8. Now what is the size of your array? Your array size is 8, right? And what is the definition of a hero element? By definition, any element which is present at least 2 times in the array, that will be a hero element, right? So if you talk about this array, none of the elements is a hero element, right? Because frequency of each element is less than 2. Now let's say if your array was like this, so 1 would have been your hero element because it is present at least 2 times, and let's say it was 6, so 6 would have been your another hero element. And considering this fact that the hero element should be taking at least 25% of the space in the array, so there can be at most 4 hero elements. And so solution for this would have been like basically 1 and 6 that you would have told. And if you modify your array like this, if these elements are 1, so again, which are your hero elements? 1 and 6, right? So that's the definition of hero element. One simple way to do it, basically what you do is to go through the array, and since it is a sorted array, so if you look at any element, if you want to count its frequency, you don't need a hash map. You just start counting from here, and as soon as the current element is same as previous element, you keep increasing that count. And when you see that count has crossed n by 4, you just add it to your solution of hero element, right? So this way you can find hero elements by iterating through it. But you are given that the size of your array is really big. It is it can be up to 10 to the power 9 elements. So big O of n is something which is not being expected from here. So when constraints are like this, you need to think about logarithmic solution. And again, what you are given here is a sorted integers array. So when you are given some array which is in sorted order, so counting becomes really easy in that. So if I talk about counting in this array, what you need to do to find whether some integer is hero element or not, you basically need to see the count for that element. And to see the count of any element, what you need is its rightmost index and its leftmost index. So I will share a video will edit to the link where I've discussed how to find the leftmost and the rightmost position of an integer. But once you find it, let's say for 1, you know, rightmost position is this, leftmost is this, and then you check what is the count of 1. If it is at least n by 4, then you say okay, 1 is hero element. So you can you would know the count of an integer in an array using this binary search approach. But how do you know which element to check for? Let's say this is your array. Now you want to check the count of ones. It's 1. Like the count of each element is just 1, right? So binary search won't really help in such a case if you are here to count the occurrence of each element, right? So you need to think about that part also for this thing. So what you are given is that for some integer to be hero element, or basically for some element integer to be hero element, it should be present at least n by 4 times, right? So what you will do is you will start from the leftmost element and you will assume, okay, I am assuming this might be a hero element. So what you need to do is you need to see the rightmost position for it and the leftmost, and then count will be basically the right index, minus left index that you would have plus 1, right? That is how you would be able to see the count of any element. So now for this element, you would see, okay, right index is here, and you would see left index is also here, right, which is basically 0. So for count of 1, if you want to calculate, count of 1 is 0 minus 0 plus 1. This is equal to 1, right? And then you compare it with n by 4, which is basically 2. So this is less than 2, right? So 1 is not a hero element. Now where the tricky part comes is, now you need to optimize this, that you don't want to check for each element. So see, you know the rightmost position of this element. Now you want to see where is the next hero element. So if you consider this fact that your hero element is present at least n by 4 times, for simplicity, let's say m is equal to n by 4, right? So now if the right element on this, basically the next element, can this be hero element? Yes, this can be hero element. But if this element is a hero element, then it would be present on such a positions that n by 4, basically m positions would have the same element. So from this index, which was your right index, you would add your m to it. So that is the position where you need to check for it. So you are on this index right now, and what you need to check is this 0th index plus 2. So that will be your second index, right? So you need to check for this element, because if this element is your hero index, then it would be present here, right? Or if it is not present here, it might be present on the right side. And now you say, I am checking for this element and I might be missing some elements in between. So see, if you're missing those elements, you don't need to check for them, because if any one of them is a hero element, that element would be present at this index also, right? Because if you look at that n plus 4, if next element is a hero index, hero element, then it would be present here, right? Let's take some bigger example. So let me add few more ones to it, few more twos. How many twos we have? 5. Let's add 3 more. Cool. This is 4. Need to add 1 more, right? So you have 4, then 4, 8, then you have this 4. All right, now the size of your array is 16, right? This is your n. So n by 4 is basically this is your n, right? N by 4 is 4. So any element which is present at least 4 times is a hero element. So you check for 1, you check for the rightmost index. So right index comes out to be 3 and left index comes out to be 0. So the count is equal to right index minus left plus 1, right? Which becomes 3 minus 0 plus 1, which is 4, right? So 1 is a hero element, and you added to the list of your hero elements. So your hero elements 1 gets added. So now you have this one thing, the right index of your current element, where it ends, right? So you know here it ends. So let's say if this element is a hero element, it should be present at least 4 times, right? So if I add this n by 4 to this, which becomes right index plus 4. So 4 from there, this is 1, right index plus 1, right index plus 2, plus 3, plus 4, right? So this is what you are checking for now. So see, if this element would have been your hero element, then it would be present here also by definition of hero element, because it would have been present at least 4 times. And even if this wasn't your hero element, and if this was the hero element, if you had such an array, let's say this 2 wasn't a hero element, but here you have 3, which is a hero element, okay? So what you need to do here is, you don't need to check for this or this element. You basically need to check for this element, which is your right index plus n by 4, which is right index plus 4. Because if any of this had been your hero index or a hero element, then it would be present here for sure, because that needs to be present at least n by 4 times. So you check for this right index plus n by 4. So with this, what you're doing is, you are basically skipping 25% elements of the array, right? And you do the same thing for this. You find the right index for this element and the left index, and you basically check the count. So what will the count? So if this is your 4th index, this is 5. So your left index is 5, right? 6, 7, 8, 9, 10, 11, 12. So this is your right index. So right index minus left index plus 1, which becomes your 8, right? So 8 is greater than or equal to 4. So 3 is your hero element. Now where do you need to check the next hero element, whether there are more hero elements present or not? Let's say this was 8 instead of 7. How do you check for it? So again, from your right index, what was your right index? This was your position. So far you have solved for your array till here. Now again, from this you will check at n by 4th position from here, like what is that element. So to your 12 you basically add 4, so 12 plus 4, so 16th index is where you check. So This was 12, 13, 14, 15, 16. So this is where you check. You check the left and the rightmost position for this. So the leftmost for this is 16. This is a 16, 17, 18, 19. Okay, did we have more elements? This is 4, 3 times. This is 4 times. Okay, there were 20 elements actually. So let's remove this part for the example. Cool. So that is how basically you would be checking the hero elements. So let's compare the two approaches. Where in first approach, where for your elements you are basically iterating through your array, and you are just checking, you are counting the frequency of each element, and then if that frequency is coming out to be at least n by 4, then that is your hero element. So this for this solution, like your time complexity would be big O of n. But when you are applying binary search to this solution, you check for the first element, then you check for the n by 4th element from that position, then n by 4th element from that position. So like in worst case, you would end up checking this thing 4 times, right? You would end up applying binary search 4 times in your array, because every time you are moving your index by n by 4, right? So when you are moving your index 4 times, you would be reaching outside the array. So 4 times into, let's say you are applying binary search on the whole array instead of just n by 4. So that would be log of n. So this becomes log of n time complexity. So let's quickly code it. So you would have some array, right? And let's say you are storing your hero elements here. Cool. So now what you do is, you say your current index. What is your current index? You start with 0, right? And you would say your n is equal to array dot length, right? And your m, you define it as n by 4, right? So you do a while loop while your current index is less than n, right? And now you see what is your number at the current index. That number is basically your element at current index, right? And now you need a function to find the leftmost position. So if we use those functions, find left position, you have an array, okay, and you have some number, right? Now what you do is you say L is equal to 0 while applying binary search, array dot length, and you do r minus equal to 1, okay? And while your left is less than right, now what you do is you calculate mid, r plus divide by 2. You have the mid here, right? If your mid array of current element is greater than your target element, then you reduce the search space in this way, where you search in the left part, right? Otherwise, if array of mid is less than num, then you search in the right part. Else what you say is you define your r is equal to mid, because that might be your answer, or your answer might lie in the left part of the array, right? And with this, from here what you do is you return L. This will give you the leftmost position. left position is equal to find left position in array for the given number, right? And similarly we need a function for the right, find right position in array. This time you add 1 here, right? So again this remains same, this remains same, this changes to L equal to mid. So how I am doing this really quick, in the video description I will be attaching one of my previous videos where I have shown how to find the leftmost and the rightmost position. So let's do this. Right position is this, and you're finding the right position, right? If right position minus left position plus 1 is greater than or equal to m, then what you do is to your hero elements you add this number, right? And now what you do is you move current index to the next position where you want to check whether that number is a hero element or not. So you say current index is equal to as we were doing the right position plus m, right? That's what we were doing to find the next one position, right index plus n by 4, right? All right. So towards end, let's do one thing. For num, for any number which is part of your where is this? Hero elements is what we are looking for. You just print that number. You'll say hero is num. Let's try to run it for this example. So we were doing one mistake which I was mentioning there, that mistakenly we counted this array as size 16 where it was 20. So the part which I explained here remains same, considering like we just removed these elements to reduce the size to 16. So I explained this solution for array of size 16. Cool. So let's use this array and find our hero elements. Okay, let's run this. So it says hero element is 1 and 3. So let's print the size also. Array size is n, right? And hero frequency also is what we do. Hero frequency is, right? Let's print these two things. So see, array size is 16. So any element who is a hero element, it should have frequency 4. And if you look at the array, so these are the two elements which have frequency more than 4. So that's how you can find hero element in an array. So basically, if you look at the problem statement, what was tricky in this problem statement? So it was a counting problem. You had to count the frequency of different elements in the array, and you had to solve for this part also where your array size is also very large. So since the array is a sorted array, you know how to count. You can count using binary search. And now to optimize, what you could leverage is this part. The frequency of hero element should be at least 4. So this is how you reduce. You don't check the frequency of each element. Once you have checked the frequency of one element, or basically very first element, you just check for the element which is at n by 4th distance from the rightmost position where you are at the current element, right? So that will give you the hero element. Cool. Keep practicing. I will share other interview experiences also with you. Thanks.